This conference will now be recorded.
Yeah, so we are pretty much into the JVM monitoring concepts because in our previous session we were checking that content only. So I'll quickly show you the course content. Yeah, so JVM performance monitoring topic only we are going to see. So I told you already all your Java program that are running on a JVM, Java virtual machine only. Through that only your Java program is actually running. Whichever the Java instance it may be, in a machine you can think like multi JVM. Okay, multi JVM. So whichever the Java program that you are running, obviously it will run on top of what Java virtual machine only. In that JVM, what is the behavior? What is really happening when you are running a particular activity? What is actually happening? That understanding only we are going to do it using this JVM performance monitoring, because that is very important, right? Because when you are running a simple program, or when you are running your application, when you are running an enterprise level, so based on your Java instance that you are trying to run it, what behavior that is actually happening in your JVM, that understanding you should get it. The behavior that I'm mentioning, right? It may be a heap level, thread level, garbage collection level, whatever. Okay, the understanding is in each level what is your JVM is actually behaving. Okay, that is where your monitoring also comes into picture. That is where your skill set is also comes into picture. Okay, it is something that you are going to identify. Is it something a heap related issue or thread related issue or a garbage collection related issue? That is what you are typically going to do it in the JVM monitor. But if you are currently taking the real scenario now, many are not actually doing it. Many are actually not doing it. I hope in this forum also it is the same case. Those are actually doing. Those are actually part of performance testing team. No? Nowadays, everybody what they are really doing, they are only doing load testing. That's all. Only doing load testing, and they are providing the numbers, and then they'll say my release activity completed. I'll move on to the next release like that. Only everybody is actually doing the same. What developers are thinking, performance testing life cycle or performance testing time period in which we will get most of our performance issues. What performance testers are thinking, these are already a streamlined code developed by a senior most developers, then there will not be any problem. So actually saying the worth of doing performance testing is actually is not there nowadays, because if you are not focusing more on the performance testing regular activities, I'm saying you are not focusing on those activities, then there is no point in doing performance testing. If you only do load testing, that's all. You are missing maximum part of your application performance issues. Load testing is nothing but you are testing the application for a expected user load. Okay, expected user load only you are testing, which means that it is bare minimum. It is bare minimum that your application is expected to work in that situation. You are not going beyond that. But your real world scenario will not be happy path at all. The real world scenario, it will vary. Sometimes it will give you low load, sometimes it will be a heavy load. But you need to be prepared for all those conditions, right? You cannot say, boss, I only did load testing. I am prepared for that load testing load only, but suddenly a huge load came to our application. Because of that reason only our application crashed like that and all. You cannot give a lame excuses. You need to be prepared for everything. You need to be prepared for everything. So make sure you have all the combination of things done. So in order to identify that, what you need to do, you need to monitor these JVM and all. If you are using a Java based application, You need to monitor your JVM and make sure your application good with heap, good with thread, good with garbage collection. All the way, all the things that are important. Okay. So for that you can do multiple options, guys. Okay. A lot of options are there in our course journey. Anyways, you are going to get all those information, but we are starting today. We are starting that understanding. We are starting like if I use JVisual VM, if I use JConsole, if I use your kit, if I use JProfiler, like that, all these activities can be done in multiple ways. Your understanding across multiple layers, whichever the tool set that are available in your organization, you are going to make use of it. Because this JVisual VM, JConsole is like a open source. Your JProfiler and your kit is actually a commercial one. But in your organization, whichever the tool that they are having, you can use. Okay, like some 2 to 3 months before, one of our learner, she uh, during this pandemic situation, she got to attend her interview from home itself. Okay, what they did is that like they sent one laptop, and then she had to attend one interview, performance engineering interview. Okay, after attending, she called me and she explained me whatever things happened. In that, there are a lot of restrictions in that laptop. Means that you cannot use these, that, like that. Lot of restrictions were there. But finally, she used JVisual VM and JConsole for providing answer for all those questions. So that is the reason I'm saying we cannot say like which tool will be available with the customer. Based on the tool that you are available, you need to make use of it. It may be JVisual VM, it may be JConsole, it may be your kit, it may be Java Profiler, it may be any APM tool, it may be any utility tool. But provided we need to have that understanding, right? So that is how we are going to start with JVisual VM today. So today we are going to start and understand like what are all the things that can be done using the JVisual VM. Okay, so I'll quickly go to just a minute. Go to your C folder, program files, Java, JDK. Inside the bin folder, you have your JVisual VM. You have your JVisual VM. You can double click and open.
You have JMC also in the JDK.
It is there, Sunil. It is there. JM mission control is also there. Okay, I opened JVisual VM. Okay, I opened it. So by default, actually this JVisual VM is also a Java content only, right? So it is showing even JStack is also running in my machine. So both the things are actually already detected by the JVisual VM. JVisual VM capability is that whatever the Java JVM that are running in your machine, it will automatically detect. That is a capability. Okay. So for now it is saying like local in the sense like this is my machine. Locally these are things are running. If you wish, you can do a remote. Okay, remote host also you can connect it. Remotely also you can do the connection establishment. Okay, so locally these two things are running, JStack and then JVisual VM. What I'm going to do, I'm going to show you examples, right? So you guys should understand things practically. So what I'm going to do right now, I'm going to my D folder. Okay, Apache JMeter. Inside the JMeter, I'm going to start Apache JMeter. Okay, Apache JMeter is a performance testing tool. For the benefit of others, it is a performance testing tool, open source performance testing tool. So I'm trying to open that. So now I open this JMeter, right? Simply I opened it. If you go to JVisual VM, you can straight away see that JMeter is actually started detecting. What is that meaning? This JMeter is a Java program which is running on top of the JVM. That is the reason it is automatically detected. Similarly, what will I do? I'll go to Apache Tomcat. Just a minute. I'll go inside the bin folder. Give me a second. Yeah, I'll try to start my Tomcat server also. So I'm starting my Apache Tomcat server. So server started now. Okay. So if I go back and see, you can see Tomcat is also started detecting. So why I'm showing this combination of examples is that like sometimes people will ask these questions. Is this a tool will do a identification of multi JVM? So you can see all these are running on a JVM and it is separately detected. Okay, so this is separate like that. So now if I double click this JMeter instance, so now only we are trying to monitor. Double clicking is nothing but you are trying to monitor that. Okay, so this is the JMeter instance that we are trying to do a JVM monitoring. Or if you wish, you can double click this Tomcat also. Double click this Tomcat. Correspondingly, you can see the Tomcat related monitoring information. Okay. So if I double click it, these are the arguments that are already inside my startup file. Actually, these things we will see in detail, but I'm just trying to tell you. See, each and every server, or I would say each and every JDK version that we are Java version, okay, Java version that we are using, we have certain default behaviors that are there. Okay, for Java 8 means parallel GC would be there. So like that, there are server configuration. I mean the Java version. There are default behaviors are there with respect to the JVM arguments. But if you wish, you can override those JVM arguments also. You can pass the JVM arguments inside your startup file. Your server startup file will be there, right? Inside that, you can override the value. Okay. So that even in JMeter also in the previous class I showed you, right? Like JMeter JMeter.batch file. Inside that I showed you the min and max size value of your heap. I showed you, right? It was how much it was before, right? Anybody can say? Min and max size of JMeter.
I think it's 1 GB.
128 and 256.
No, for JMeter it was 1 GB. JMeter 1 GB.
JMeter we changed to 1 GB, 1 GB min and max.
Yeah. That's what I'm saying. So JMeter, the default min and max configuration is actually 1 GB. Okay. So now for our example, for our better clarity, in Tomcat I added 128 MB and 256 MB as a value. Okay. In JMeter that was a different case, and then here it is actually a different case. If you go to JMeter instance monitoring, okay. In JMeter instance monitoring, the heap setting is actually available here, and then Tomcat. If you go here, the heat setting will be available here. So there will be a graph which is actually going to help you to say like whether you are going in a right direction or going in a wrong direction. That is what I'm going to show you right now. So I have my Tomcat monitored by this JVisual VM right now. Okay, under idle situation, I did not do anything till now. I did not do anything under idle situation. It is going around like used heap is actually 56 or somewhere 60 till 60 level, 62 MB level. It is actually trending. Okay, it is idle situation. I am not doing anything. I'm just I just started the server. That's all. And your CPU usage and all also, it is actually under normal situation only. Nothing is actually going beyond. Okay. So what I'm going to do, I'm going to open a sample script. I have a sample script available in my machine. I have a sample script. So I'm opening that. That sample script is prepared for my application only. My JPEG Store application only. That sample script is actually prepared. Okay. So now if I try to use this script to hit my application with a 10 user load. So I start the test now, and then we'll see the traffic started coming. Yes, it is started coming. And if I go to straight away, you will see the change in your JVisual VM graphs. Like your CPU usage started spiking, your heap usage started spiking, your class level and your thread level, all those things started spiking. Okay. So this behavior, which is going to tell you with the 10 user load of traffic that we are creating in JMeter, and that traffic is actually hitting my Apache Tomcat through Java application. So what is the behavior that is actually happening? You need to say like you are doing a load testing for 1 hour. So you need to observe this behavior for 1 hour. Okay, you need to observe this behavior for 1 hour. And you can take an informed decision like whether you are doing good or doing bad. Okay, guys, give me 2 minutes. I'll be back. Yeah, I'm back. So now you will see the pattern that is actually coming here, right? Like your GC, I mean your CPU is actually trending like this, and below to that there is a slight GC that is actually happening. You can see in the bottom of it there is a 1.1% or something like that. A GC activity is actually happening. Okay, and simultaneously, if you go and see like your heap utilization is actually to the max, it is actually going this much level only, which is actually normal. Okay, simultaneously, if I go and show you the JMeter, because JMeter is all, we don't want to monitor it. Don't think like we have to monitor JMeter. For your example, I'm saying JMeter you don't want to monitor at all. Your application only you have to monitor. But for your example, I'm trying to show you. So JMeter, if you go and check it, looks like the upper boundary is actually 1 GB, right? So you can see automatically it is actually increasing the available thing, and you correspondingly your heap is also utilizing. Okay, say like I'm suddenly stopping this test. Suddenly stopping this test. Okay, so what will happen? The traffic is actually stopped. The system should come to the idle position, right? Normal position it has to come. So we'll wait for some time. We'll see that behavior is actually happening or what. Okay, it was somewhere uh, 50 or 60 only we saw the heap utilization, right? So now I literally stopped the entire load test. Okay, so we will see within 1 minute what is the behavior that is actually happening. So now the looks like the curve is flattened only. I mean that the load actually stopped. But did you see it is actually straight away coming to your zeroth position? Is it coming to the zeroth position or where it is actually standing? Anybody can comment on this graph?
Standing in the same position.
Yeah. So that is what I'm trying to explain to you. So we should not have the false understanding when the test completed, it will come to the zeroth position. It will not happen at all because the accumulated memory is still there in the cache. So unless and until if you are not restarting the server, it will not come back at all. It will not come back. It will stay in the same position only. Okay, it is for this scenario. If I say like it was initially somewhere here and then it went to here. Okay, okay, similarly if I go to the Tomcat also, it is somewhere here. If I mouse over it, it is holding 63 64 MB right now, which means that on an average it is actually consumed 5 MB 6 MB extra. Okay, so that is what the behavior. And if you see the same behavior in JMeter also it consumed a lot because JMeter stores a lot, right? So you are having the listener and all added inside, means lot of results will be stored. So obviously your Java memory will be very, very high. Okay, your Java memory will be very, very high. But that too, I'll tell you, this is actually a long-lasting problem with JMeter. Say like if I again start the same 10 user test, I'm starting a 10 user test again. So test started triggering. If I go here, so what will happen? You can see a sudden GC will be happening. probably a major GC usually. Okay, so a sudden drop happened and then started accumulating again. Started accumulating. So what is happening? It was before 789 or 7, probably 796, 800 and all it went. Okay, close to 800. It was under the idle state. It was 800. Now if I mouse over it, it is actually more than that. Okay, it is 828, 870, 830, like that. It is going. What is that meaning, guys? Anybody can, in a simple nutshell, anybody can explain what is happening here? If I again started the test, what is actually happening?
It is actually going forward to available memory.
Yeah, that
It
is the point. That is the point. What I'm trying to explain is that, say like you started the first test. Yeah, this is x-axis, y-axis. Okay, so you started the first test. It was like this. Okay, when and you stopped the test. You stopped the test here. Okay, you stopped the test here, and then you started the test again. What happened? A slight GC happened, and then again it is actually going like this. Okay, so which means that unless and until you are not restarting the server and you are simply holding the same instance and then you are trying to restart the test, means within very few minutes you will reach your maximum and you are started, you will get out of memory error. Out of memory error. Okay, so that is the reason. That is the reason we are running the JMeter test in what? Non-GUI mode. Okay, non-GUI mode. We will do the JMeter test execution, which means that if you are physically launching your JMeter, there will be a memory accumulated by JMeter, and then each time if you are trying to run the test, means your heap size will be keep on increasing. At one point of time, your heap will be full and you will be getting a out of memory error. Clear? So this is just an example that I wanted to show you. So each and every time, if you wanted to have a perfect behavior in certain organization, they will insist you to restart the server before your performance testing activity. In any of your organization, they are insisting like that. Do the restart before doing your load testing.
Yes, sir, Anand. So
Yes.
we used to do it.
Okay.
Yeah.
Okay.
Before
Yeah.
starting any test, all the app servers and the respective web servers, we get them recycled, or we restart all that to get things
Yeah.
to the initial state.
Yeah. So actually, why I am asking this question? Many organizations, they are not actually doing it. They are not actually doing it. But in certain organizations, they will insist you to do so. And in certain organization, what they will tell you, do the restart, log in as single user, and then do the server warm up, and then do your activity. It is like one user warming up the server. It is maybe either you or from somebody from infrastructure team. They will do the server warm up, and then they will use it. In certain organization, they are following this as well. So now what we are clearly visualize is that, like, if you are trying to monitor this kind of JVM things, based on the load that you are giving, it is actually doing the increment in your heap, increment in your CPU, in your thread level also, and then your class level also. Okay, so you can see this is actually, for now what we are monitoring is actually Apache Tomcat. Look at the way here. It was somewhere the available heap is, it was like 134348 byte. Okay, just a minute. So somewhere this is the number. Okay, whatever you are getting it here, right? It is actually 128 MB, the bottom range that you gave, right? That is actually converted into a byte, and that byte value is actually this used memory, the top orange line. Okay, and over certain period, your memory is actually what? Your memory is actually reached to that level, and it increased that boundary because the upper boundary what we gave. Somebody can answer. Upper boundary what we gave?
256 MB.
256 MB, wonderful, yeah. So till that level, you have the cushion. So starting with 128 MB, cushion is still 256 Mbps. So that is what here it is actually happening. The one step is actually increased, right? It is something that it is elasticity. It is increasing the memory based on your hit that you are trying to get it. But the graph is actually what is happening. It is actually exponentially increasing exponentially. Your graph, your any memory graph that you are trying to observe it, right? Your memory graph should not be like this. Your memory graph should not be like this. Like this, it should not go. Like this, it should not go. Exponentially, it should not increase. Your memory graph should be somewhere in parallel to your x-axis. Like that, it has to go. Then only your memory graph is actually healthy. It is not having any problem. It is actually healthy. But if it is trying to go exponentially increasing means, then it is meaning that somewhere something wrong. What may be the problem? Anybody can answer. What may be the problem if it is exponentially increasing?
GC is not happening effectively.
Yeah, correct. GC is not effectively happening. Your GC is unable to clear the unreferenced objects clearly. That is the meaning. Okay. So two example we saw. One is JMeter. Another one is your Apache Tomcat. JMeter, I told you long lasting problem is there. If you are running it physically, there will be a memory problem. That is the reason people nowadays going on with the non-GUI mode. And then you also have the option to increase your min size and max size in JMeter, not only in JMeter, in all the JVM arguments. Similarly, I showed you Apache Tomcat monitoring. Purposefully, I gave a very minimum memory in Apache Tomcat, 128 and 256 is very, very minimum. And I started providing a traffic, how the memory pattern is actually happening, and how, say, where there is a dip right here, it is like a sawtooth wave, right? Where there is a dip, correspondingly, if you go and mouse over in the CPU graph, definitely there should be a GC activity will be happening. So where there is a dip means that GC activity is actually happening. Okay, GC activity is happening. That is the reason it is showing a dip in your graph. Okay, I'll take a pass here. Anybody have any question till now?
Saravanan, I have one question. Like you
Yeah,
said,
Subbu.
like the heap size did not come back because the GC was not happening, but I could see the GC activities happening continuously, right? So why did it come back to the original position when we stopped the first test?
See, that is what I'm saying. Under idle situation, if you are doing a restart or you are doing a garbage collection, what will happen? It will go and check the referenced and the unreferenced. Garbage collection means what? It will check the unreferenced objects. That unreferenced objects only your garbage collection can clear. Okay, but there are instances what will happen. The objects are referenced, but it will not be used anywhere in the application by mistake. I'm saying, okay, by mistake or by logical mistake, they will be referencing the object, but they never use that object anywhere in the application. Okay, those are unable to clear it by your garbage collection. Okay, because unreferenced objects only garbage collection can clear. Referenced object garbage collection will not clear. But referenced objects are staying in the system, but it is not used anywhere in the application. Means what will happen over the period? What will happen? There will not be any new objects coming to your system because the older referenced objects is not still staying in the system. So that kind of an objects are called as memory leaked objects. Those are leaked objects because unless and until if it is not going out, no new objects will be coming in. You're getting my point, Shukla?
Yes, yes.
So those are something like you need to take care that whether we need to have these objects, whether we don't want to have it, what are referenced objects, what are unreferenced objects. Unreferenced objects, say here in JVisual VM also you have a option to do. You can see here perform GC is there, right? I can still click it. Did you see that straight away a change in the graph?
Yes.
So it is to check. It is to check if I currently inject a perform GC. If I currently inject a GC, how much of a memory that I can regain? It is to artificially inject it and to see like if I currently inject a GC, what will be the behavior? In Java, it is implicit GC, right? So even if you are calling the GC, what is happening? That behavior also you can validate it. You are getting my point?
Yes, Ravanand.
Yeah. So what this JVisual VM tool is actually used for, the JVisual actually saying it is used for multiple purpose, but till now what we observed, I'm saying, till now what we observed when we are doing a load testing, stress testing, endurance testing, whatever the testing that we are trying to do, that time we can come and we can monitor the respective JVM. In our case, we are monitoring the Tomcat server now. While doing the monitoring, on an average, some 40% of the CPU utilization is actually happening, and on an average 0.5 to 0.6% of the GC is actually happening, and we have the heap utilization trending across which level. Even we can go and see the metaspace value also, what is actually happening in our POM generation, right? That value also you can validate it. And the class counts, what are all the classes that are loaded, that information, and then your thread counts. Okay, how many are in this, how many are daemon threads that are running, that information. So this is actually a summary view, which is going to give me a CPU level, memory level, class level, thread level understanding will be there. Mostly our intention is to see the CPU graph and the memory graph, because in the CPU graph, our individual JVM, you take a look, this particular application is actually taking 47%. Individual process, I'm saying, this individual process is taking 37. And then if I go to JMeter, that is actually individually taking probably 10.5. Just a minute. Yeah, probably it is taking close to 13. Sometimes it is going till 17 and all. Okay, so if I go to the system CPU in my task manager, so you can see it is 100%. So collectively, my JMeter, my Apache Tomcat, and other process that are running in my machine, it is collectively 100% CPU utilization. In that, individually, this particular Apache Tomcat server, our server alone, it is taking 47 to 50. Okay, so you make sure you have to segregate in this way. Okay, individually, my application server itself taking 47. But you think about in a physical server thought process. In physical server, JMeter and all will not be there. Only your Apache Tomcat only will be there. So your Apache Tomcat, how much of a percentage it is actually taking? If it is somewhere 70 or 80, means you need to take a look. Okay, CPU utilization 70 or 80. What about correspondingly garbage collection is actually happening? Correspondingly, what is happening to your heap utilization? Is it well under the range, or it is going beyond certain value, and it is actually trended across x-axis, or it is exponentially increasing? That understanding also you will be checking it. That is what you are doing it in this JVM monitoring, this particular tab. That is what you are trying to do. I'll take a pass here. Anybody have any question till now?
The classes graph, where we are seeing the total number of classes loaded. So usually the class related data is loaded into metaspace only.
Classes, memory only metaspace. Class is class, right? Class is actually number of class that are loaded. It
Okay.
is not telling the memory, it is telling the count. Yeah, your
Okay.
do
Count
class
of-
level data is actually stored in the metaspace only. This is actually
Oh,
telling the count of the class.
okay.
Yeah. So this tool, this utility tool, JVisual VM, it is like a kernel level understanding. Whatever we are trying to see, it is actually kernel level. Okay, on machine level only you will be getting it, not something on the user level. User level means what? This is actually the user level, right? If I right click, so I'll stop this test for some time, which is eating my CPU a lot. So if I open that application, Naresh, we are monitoring memory stats also, Naresh. In memory means what? Which in memory you are saying?
RAM.
Is it
I
some?
mean RAM.
Yeah. So RAM size, say whatever you are asking, no, it is a total RAM size, right? That level it will not provide. It is a Java oriented information only. You whatever you are asking, right? That we will cover it in the infrastructure monitoring session, Naresh. Okay.
Can we suggest like for monitoring load test? I mean JMeter monitoring. I'm running a load test in a machine. So can I
Mhm.
monitor the same using the JVM? Is it suggestible, or we have to go for a performance monitor? A Puffman,
No,
I mean a Puffman.
see what you are expecting. You wanted to monitor your application or what? Which one you are trying to
Not, not,
monitor?
not application. I mean, not application. I'm saying. See, I wanted to run a load test for huge user load. So I just wanted
Okay.
to measure whatever the my server is reacting for the JMeter load running. So should I go for JVM or a Puffman is a better? Because Puffman will write the logs in backend, right? So here JVM is the application itself. So is it take a lot of memory to launch the JVM itself, or should I go for Puffman like to monitor the load JVM tool? Sorry, JMeter tool.
See, that is what to monitor JMeter alone, you go to JVM monitoring. If you monitor JMeter sitting on a particular machine, that machine you want to monitor, go to Perfmon. It is up to what you are monitoring. You only monitor JMeter means you can use this JVM option. Okay, but when JVM is running on top of a Windows machine, what is happening? That understanding you wanted to get it means you can use the Perfmon.
Yeah. So here JVM, whatever the JVM you are launching, right? JVM itself takes some memory and CPU utilization, right? So
Yes.
will it use affect the load test, right? I mean, like tool itself take some CPU utilization, memory utilization. If I launch JVM itself, it will take some memory and the um, RAM utilization, CPU utilization. So do I get to know whether how much JVM itself will take huge memory, or like how much memory it takes?
See,
Memory CPU utilization.
that is
Yeah.
implicit that when you are trying to do a local host monitoring, obviously there will be some consumption. That is the reason I also mentioned there is a remote option is also available. Remote option means what? Somewhere your testing will be happening. Remotely you can connect and then remotely collect the data. Your monitoring data, you can collect it remotely. That option is also there. Even you wanted to do a local level monitoring, like whatever the Java things that are running in your local machine, that will be detected and then you are trying to. So either way you can do it. If you are trying to do locally, true, it will definitely store some data, take some CPU. Definitely it will be a overhead, little overhead will be there. We cannot deny that. But nowadays, that too, when you guys are doing it in a auto scaling environment, elasticity environment, this kind of a small overhead people are accepting. Okay, they are accepting, and there are enterprise level organization where they are not accepting. You try to go with the remote option, where they are saying like, no, if you are running it on-prem, lot of storage will be there, lot of CPU will be there. We will not allow you to do all these things like that. If somebody is talking, that time you can go with the remote option. Still, you can go with the remote option. It is there. Remote option is there. But if they are not saying anything for that, okay, for them these are very small, very granular. Only you can still go with the execution like that. If somebody is saying, good to go with the local execution itself. Clear, Naresh?
Yeah, clear. And one more doubt. Here in Puffman, we can write the logs, and then later we can pulling the metrics and we can show the graphs. But in the same way in JVM, without directly launching the application, can we write the logs and can we get the graphs? This kind of feature is there?
No, it is something that you can on a go you can monitor it. That's all.
Okay. Yeah. Okay. Thank you. That's it.
Yeah. But I don't want to literally reject your words also. I'll take this and then go back and then validate. Is there any utility tool that is available in the market that will leverage JVisual VM and try to write any log or what? That I will check it. Maybe you ask this question, right? Because as far as I know, it is not there. But I don't want to reject your words. I'll go back and then check it. Like somebody is actually internally using the JVisual VM and then trying to write any log or what. That I'll check it and then I'll tell you. Okay.
Yeah. Thank you.
Yeah. Sure. So till now, what we saw, the monitor tab. Okay, the monitor tab in which we are validating the CPU, memory, class, threads level understanding, and how your the min and max value that you set it up, right? Like I showed you how to set it up your min and max, how to set it up your metaspace value, and even you can validate these two graphs over the period. Your metaspace value, how it is actually consumed. Say, look at the way here. Looks like your metaspace value is actually less, and it is exactly in parallel to your used metaspace is also like this only. But it is not still facing any problem. But I'm telling you. So I told you the metaspace usually will be 64 MB multiples, right? So in that way only it is available. Here also your heap setting is also 128 MB multiples. So it is exponentially increasing. So somewhere you feel like there is a memory problem that is happening in this application. That is what the feel that we are getting it. That too, we are running this probably for more than 30 minutes, right? So obviously we are getting some pattern. Your heap utilization, how your application is actually used, and over the period how it is actually behaving. That kind of an understanding we were able to get it. And I also showed you a GC, artificially injecting a GC, and what is the behavior that we are trying to get it. That understanding also we got it. Okay, so the next tab is actually I did not explain the heap dump till now. Okay, we'll see that. Okay, till now I did not explain this button. We'll go to the next tab, which is actually thread tab. Okay, so here also all your internal thread that are running, daemon threads, non-daemon threads that are running, right? That is actually mentioned here. Okay, and in this JVisual VM tool, whatever it is there in the green color, it is running, purple sleeping, yellow waiting, brownish it is actually park, and then your monitor status will be in the kind of a pink color. Okay, so running means currently the thread is actually running and it is performing certain task. Sleeping means thread.sleep. The thread is actually in the sleep mode. Waiting means it is waiting for some other activity to be completed and then it has to carry out the regular activity. So that is waiting. Park is nothing but before running status. Before running, which means that thread created and it is not taking any activities till now. It is actually in the park status. It is actually in the park, which means that yet to take the new task. And then monitor status, actually I told you, it is actually a blocked status. It is actually blocked, the thread blocked for some activity. Say like I am giving a print to a printer. I'm giving a print to a printer. In the meantime, Naresh is also giving the print to the printer. In the meantime, Srikanth is also giving a print to the printer. What will happen, guys, in this case? What will happen?
Queuing will happen. Maybe.
What will happen? Your voice is broken.
It will go in queue.
It will go in queue, means that my request will be completed first, and then Naresh, and then Srikanth. That is the sequence, right? That is all. So a thread will be initiated. It will be there in the park status for some time. It will first take my request running, and then it'll complete and it will go. So this is a sequence. So park status, something before running status is taking the task. Waiting status, thread.sleep, it is actually sorry, sleeping status is nothing but thread.sleep. Waiting status is nothing but waiting for some other activity to be completed. Monitor status, it is actually under the blocked status. Okay, so you have, these are the different threads. Okay, threads that are running. It may be your kernel threads, or it may be your user threads. Okay, user threads, non-daemon threads, kernel threads, your daemon threads, your daemon activity that are actually happening in your thread. Okay, any question, guys, till now? Anybody have any question till now?
What will be now we are seeing all these threads and the different states they are in. So if we have to now in GC, we know like unreferenced objects, or there is scope for improvement in performance. But in threads, what would be the what will be that scope when we are doing the analysis? What ideally we need to look at for identifying improvements or performance bottlenecks or degradations?
No, see, it is obvious that your thread should not be in blocked status continuously. That is the primary monitor status, I would say. Okay, the thread should not be there in the monitor status all the way. Say minimum time. Say when I'm giving the print, and that time you are also giving the print, means that moment it will be there in the blocked status. But that I should not give some 1500 page print to that printer, means you will be infinitely waiting, right? So continuously blocked. That printer is continuously blocked for Saravanan. So you need to think, you need to understand the waiting status and the blocked status and even the running status. It should not be infinitely doing, or it should not be longer period of time. It should not longer period of time it should do. Okay, so make sure your status of threads should be a precise time, minimum time only. It should be there in the monitor, it should be there in the waiting, it should be there in the running. Okay, if it is prolonged, then it is a problem. That is the only thing we need to validate when you are doing your thread analysis. Clear?
And we see some threads are continuously running RMI, TCP, accept
See, some machine level threads will definitely be running. Some machine level threads will be there. So you need to mostly you can think about machine level threads in the later part, but your concern is your user level threads only. Okay, your non-daemon threads only you need to focus on, because that threads only handling your code. Okay, your user activities that you are doing, right? That is actually non-daemon threads only taking care. So you need to make sure that your non-daemon threads, how it is actually working. Clear?
How will we identify that? Like anything, if there is, suppose there is one thread exe-9, and if it is for a longer time in await mode or sleep wait mode, then if we have to go and look into it, what is that activity which is getting blocked? How do we do that?
We have to take the dump. I'll explain that in the subsequent session. We are going to see that. Okay, we'll take the dump and then we will understand. Okay.
Yeah. Okay.
Sure. So with this, probably we'll wrap up for today's session. We'll regroup tomorrow for our further understanding. Thanks for joining and have a nice day. Bye-bye.